All right, so this guy spins nicely now that we shimmed this out. They can't get needles into the bearings. I have some new gears, and these guys, you know, rather than ream these out to 1/4 inch, which I made the shaft, why don't I just make the shaft fit these, because these are all 6mm because they're metric. So we're going to pop the shaft out of here, and we are going to reduce the diameter to 6mm. On the rear of this rear plate, I'm going to pop a couple holes in 2 directions, one oriented this way, one oriented this way, so that I can mount this little motor there, which I'm going to create an eccentric, I don't know, what would you call it, mass that's going to spin on the end. And the whole point of that is to cause vibration. And I don't know if the vibration will be better this way or this way, so I'll give it both options. I'll set it up for both options. I'm going to have to make a piece of metal to hold that up against the flush against this. We'll do all that next. First, we're going to reduce the shaft. So guess what? Got to take this apart for the 4,327th time. And we're back. We're going to take this part that's 0.250 and take it down to 0.236. Then as long as I'm at it, I'm going to flip it around and do the same to this side. Might as well have 6mm on both sides. Right, seems reasonable. Shoot for 10 thousandths. I know there's an aluminum cutting bit, but it gets a nice finish here, and it can reach in. It's a very sharp point. So it's great for small parts when you want to reach in. It's a positive rake insert, so it's a low force, less likely to deflect the part. That's why we're using it. And to test, it's a couple tenths over. It's a snug fit, which is good. I like that. Kind of stopping at the other side. Oh, there's a set screw protruding. Yeah, that's perfect. All right, so we're good to go here. I'm going to flip it over, do the same thing. All right, so we've got this aluminum piece squared off here. We're going to cut a little slot down the middle, the width of this motor, and it's going to go most of the way through the motor. It's going to leave a 1/10 of an inch clearance, and that's going to be used to clamp this motor down securely to the 1/4 inch plate, so that the vibrations won't get absorbed in a bracket or anything like that. We want the vibration straight in the machine. I'm not sure if this little motor is adequate, so this is just sort of a test real quick. And if it works, then we'll go with it. Yep, there we go. Just a couple thousandths away, so that should be good. All right, now we can flip this over and drill some screw holes. Now we need to countersink, and the depth needs to be somewhat precise because I want the combination of the countersink to create the screw, so that the screw depth will not go all the way through the 1/4 inch material on the other side. That's important because that's where the needles are, and I don't want that protruding and getting in the way. So we'll use our quill depth setting. We're going to go in 0.3. A little bit fast for this. So I was shooting for a 1/10 of an inch plus just under a 1/4 of an inch. So the combination of these two should be less than the 0.35. I don't want to go through the 1/4 inch plate, which is here, which is part of my point. Alrighty, then we're going to take it over and tap it, and then we can put this thing together and see how close we are. All right, so we're ready to assemble this again. And remember how I say it's 1 step forward, 3 back? Well, or 2 back as the expression goes. When I made these square and they lined up, they were actually overlapping this hole. So what I did was I just took this out to my cleaver and cleaved them at an angle roughly equal to the angle that these plates are at. And so now they won't stick out and cover the motor mounting area. I just have done a really poor job at foreseeing things. And I'm sure what a lot of people say is you should just lay this all out in 3D CAD, which I did originally lay this out in 3D CAD, but some of these other parts I didn't bother modeling, and I guess that's my bad. Did I say assembly? I didn't mean assembly, because this little motor by itself is not going to vibrate anything. I need an eccentric weight on the end of this, so we got to make one. I kind of feel like I'm a bad joke in a situation comedy. You know, I got it, and I don't got it. You know that expression, right? Well, that's been this project, but I guess for prototypes, that's to be expected. I haven't done a ton of them in my lifetime, so those that have are probably snickering and going, you should have known, because they're always like that. I don't really know how much weight this motor can handle. The shaft isn't very long. So I've got a drill truck and a drill chuck. This is a sensitive drill, so it floats, and all the force that you apply is from this guy right here. Probably should up the RPMs quite a bit. Especially for the drill bits I'm going to use next. This should be a few tenths undersized, because I figure it's going to drill oversized. I don't have a reamer this small, I don't think. So I want this to be a slight press fit. And the drill drilled way, way, way oversized. Okay, that's my bad. I knew better. Alrighty, let's do it again. Here we are for round two. I'm getting very good at round two. Okay, well, let's see how that one fits. That should be a couple tenths under. That's worse, BB in a boxcar. And that's probably because it's not a floating holder for the reamer. Okay, I have to figure this one out. The other solution would be to buy an inexpensive motor on Amazon for like $3. That's a vibrating motor. That would work too. Try number 3. We have a reamer, the appropriate size. I forgot I had a numbered index of reamers, not entirely populated, but I did have 0.076, so that should be a couple thousandths under, and if I'm lucky, even if it wobbles, it'll work. We'll see. So this drill bit should be 0.0625. All right. And now we go for the 0.076 reamer. Although that's where it is in the index. To be honest, I couldn't read the numbers on it. It's not very deep, but maybe it'll be enough. Hey, look at that. I can't even get this one started. So this is too small. I've always had too big. So I'm feeling like I'm going to try and channel Mr. Robin Renzetti, and I'm going to try and use some lapping compound, and this is 35 micron lapping compound, and I'm going to try and lap out the whole. I only need 1,000th, so maybe that won't be too hard. I have zero experience in this, so let's give it a try, or maybe we'll make in part number 4. I'm using a 1/16 drill bit here. If I had a 1.95 inch, a 1.95 millimeter drill bit, that would be pretty close. So you can see that it did take some material off the drill bit, the harder material. So maybe it took some off the brass as well. Let's see. Nope, can't start. This is non-impregnating lapping compound, so I hope that the lapping compound isn't embedding in the softer material. This stuff breaks down and gets finer and finer. That's why I chose it rather than diamond. I can tell you it's doing a great job lapping the drill bit tip, which means maybe it is just sticking in the brass and not really removing much, because it doesn't seem to be getting much bigger, but it is lapping the drill bit tip pretty fantastically. It's great. It took out the black oxide finish off. It's really nice looking. So unfortunately the brass is soft material, so I need something softer, and I'm not quite sure what I'd have that would fit that bill. So lapping may not be the solution. All right, so the lapping was a failure because brass is softer than the steel of the drill bit, so the drill bit was lapping instead. However, since drilling with an undersized drill but letting the chips pack a little bit made the drill bit precess and make the hole larger, I decided to go with an undersized drill bit, and look at this. I might be able to squeeze that on. It's pretty tight, but it starts. So to test my theory, we're just gonna have to go for it. I'm gonna part this off. The whole time recognizing this would be much easier. This would be a whole lot easier if I just bought the motor for almost nothing. Now we're going to make it eccentric by shaving off most of the material off one side. Okay, now I'm just going to go plunge straight down the sides to remove even more material off the center line. And I guess I'll call that good. All right, after false start number 37, I think we're ready to go. I just got to solder some wires on this guy real quick. So I'm going to prep the wires to solder these guys on. We're just going to tin them here. Oh, this is crappy PVC wire. Melts at a fairly low temperature, so you end up chasing it back. Have my soldering iron a little hot to warm it up, but that's still common with PVC. Doesn't matter which direction this motor goes, so there's no polarity to worry about. So I've got a new tool in my arsenal, these Bic lighters with the extended tip. They're pretty handy for getting a flame in close. And I know I should use a heat gun, but lighters are very quick, and for most applications they work all right. Okay, it clears just barely. That's the whole point of it. It's got like 50 thousandths clearance. So I think we want to make it go like this rather than vibrate like this. So we're going to mount it this way first, and if that doesn't work, we'll try something else. We'll try the other direction. Now, if I'm not a total knucklehead, once this guy gets tight, these should not stick through. And look at that, the screws do not stick through. That's important, because I don't want the pins that are sliding down here to catch on the edge of a screw thread, so that's great. Put this guy on. This is the back. Got a lot of experience assembling and disassembling this, got to tell you. And I almost forgot putting in this guy. Well, that's better than last time for sure. The friction's a lot less. You can see here, trying to get this 1/4-inch wrench in here is a little bit fiddly. Okay. But it looks like we got that in there successfully. Now I just need to get this guy lined up. So here's top dead center. All right, well, we're here with the 2 gears, and I was ready to start working on the last piece here that would direct the needles to the center of this. There's only 100,000 spare play, but they don't tend to roll straight down just because there's enough friction, I guess. However, I discovered that there's enough momentum because of the weight of this shaft. You know, it's a 3/4-inch round 4140 shaft, that even with these tightened up all the way, the shaft's slipping inside the gear with 2 of these. So we've got to put some flats in it and give it a weight so that this doesn't go out of location, because once it moves out of location, you won't load any needles anymore. So I got to take this whole thing apart again. Surprise, right? Keep as much debris as possible out of the spring. I have covered it in tape. Hopefully that'll work. And then I've got the 2 spots I've marked through the gear, and we're going to try and put some sizable flats there and see how we do. So rather than take this guy apart, I did this guy in the vise, holding the shaft that goes through on the other side. It would have been nice if the shaft had been longer. To work on this side, I put some sandpaper around the shaft, vice grips on the sandpaper, and then clamped the vice grips in place. And that looks like it's pretty solid. So we're just going to file this flat and see how it goes. And by miracle of miracles, it seems like we're good. Turns out I only had to file this one at the end, and I filed on the wrong side. So I damaged the shaft unnecessarily, but it's okay. This one is holding. This is the one with the mechanical disadvantage. When all of this mass stops moving, you've got a mechanical advantage trying to rotate this one around its tiny shaft because of the big torque arm there. Fortunately, this one's holding nicely, and looks like we're good to go. And the larger gear with 2 extra teeth is ending up at the right spot. So, all right, so we've mounted the vibratory motor on the back here, and we've loaded some needles in there, the 7 I have, my examples. I'm not going to bother trying to control the solenoid. I'm just going to manually actuate it. So here's 1, 2, and look at that, jammed. Okay, so let's power up the motor and see if the vibration lets the needle preload. All right, so you can see it's not preloading. Vibrator is going full gas, but no loading. If I take that and put it down there, get 2, and then it jams. And that was 4 in a row. So this thing's so massive that even though it's a fairly big offset weight, it doesn't feel like the vibration's doing enough to allow this to load. Got 2, 3. And it has to get one every time, or the robot arm and laser welder will waste a complete cycle. Nope. Well, that's a fail. Next idea.